Hello there folks, and welcome to video number 211. This one is on the and/or rule for conditional probability, and the keywords I've got for you are and, product, or, sum, and conditional, all explained in previous videos. But and product refer to multiplying in this context, or and sum refer to adding, and the word conditional means the same as dependent. Now, in the world of probability, the chance of the second event happening can be either conditional or dependent upon what's happened in the first go, and that's what these questions are about. Okay, so the and/or rule for conditional probability is used instead of using a probability tree. It's what you do when you've got stuff that goes on more than past two events. If you watch that video, you'll understand what I'm talking about. Work on the probability of the first event and multiply that by the probability of the second event, given that the first event has happened. Okay, theoretically. So keep going if there are more events. And do that until you've finished the question, basically. So we use this formula, basically. Probability of A and B happening is equal to the probability of event A multiplied by the probability of event B, given that event A occurred. It actually happened. All right. So in question number 1, there are 10 socks in a washing bin. Everyone can picture this. 3 of them are blue and 7 are red. What's the probability of picking a red, blue, and then a red sock from the bin in that order? Okay, so you imagine you could do a probability tree for this, but it's 3 events, so the tree gets big quite quickly. All right, so what we do is we just think about the probabilities, okay, and know that we can use this rule. So the first sock there is that red one, so the chance of it being red is going to be 7 out of 10. Okay, then we're going to multiply it by the chance of getting a blue one, because we want it in that particular order. That's going to be, well, there are 3 blue ones still there because we didn't pick a blue one the first go, right? Theoretically. So that would be 3 out of, but this time it's going to be out of 9 because there's 1 less sock in the washing bin. Okay? Didn't get put back in, so there's 1 sock less. Hopefully that makes sense. And then we multiply by, and we want a red one next. Well, we got a red one on the first go, so there must mean there's 6 red ones left, and then there'll be 8 socks in there because we've taken 2 socks out of that washing bin. All right, it's thinking logically, basically, and then we just use our math skill to multiply the fractions together. So 7 times 3 is 21, times it by 6 is whatever it is. I'm going to get my calculator in to multiply these fractions because it's going to be a bit easier. And there it is. So, yeah, if we just do 7 times 3 times 6, or we can multiply the fractions straight away if we want. So 7 over 10, and then we multiply that by the 3 over 9. Oops, we need to press the fraction button first. Always forget that on this old calculator. If you've got a new version, you don't have to do that. You can just press the number, and then the fraction button, and then the other number. But there we go, there's our fractions all multiplied together. 7/40ths, that's an answer. That is an acceptable answer. You might want to change it to a decimal, whatever, but there we go. That's going to do for me. I'm happy with that. Simplified fraction. Okay, now, and you would take any equivalent to 7/40ths as well. That would be acceptable. You don't have to necessarily simplify if you did do it without a calculator. All right, so second question is Simon buys a single lottery ticket. To win the jackpot, he will need to get all 6 of the numbered balls on his ticket to be drawn from the machine. The balls are numbered from 1 to 59. What's the likelihood of him winning the jackpot? Now, this is how the British Lottery, National Lottery, works. All right, this is exactly how it works now, at time of recording, at least. It did used to be less balls in there, but now they're 59. Now, this is exactly the same logic as the first question. So it's thinking about how many numbers have you chosen out of the total numbers that there are. Okay, now a lot of people think the lottery, some people think is 50-50 chance of winning because they think you either win or you don't, which does make me laugh when I hear people say that sometimes. It's quite a funny way of thinking of it. But it's not quite correct. So you have to think of how many of the numbers you're allowed to choose, right, which is 6 out of 59. All right, then you're going to multiply that using this rule, right, because it's a conditional probability question. You're going to multiply it by 5 out of 58 because there are 5 numbers left on your ticket if you did get the first one, which you would have to if you were going to win the jackpot. You have to get them all. You've got 5 options left, and there is 58 balls left, and then it just keeps going down like that. So we're going to get 4 would be the next number, out of 57, and then 3 out of 56, 2 out of 55, and 1 out of 54. You have to multiply all of these fractions together to get your answer. So if we do that, just drag the calculator over, we clear the screen, press our fraction buttons and type these in. This is actually going to give you a really good idea as to whether you should play the lottery or not. Obviously the lottery does do a lot of good things for a lot of people with the money that's raised, so you might just play with that kind of context in mind to kind of give a little bit of money back to some charities and things like that, which is a nice thing. Or the British Olympians, they benefit from lottery funding. Lots of people do. But if you were playing just with the sole purpose of winning the lottery, then it's probably not worth it, because that's your chance of winning. All right, chance of winning is 1 out of every 45,057,474 times that you play it. Okay, so that's that, and I can't remember that number exactly, so I will have to look at the screen again. I think it was 57, 57474. That is your chance of winning the lottery in Great Britain. Pretty low chances, I'd say. Now, let's look at this third question. All right, what we've got is a question that's a little bit trickier. Sarah has 3 1p coins and 9 2p coins in a purse. I'm just going to pause this a second. Sorry, just had an interruption there, but back to it. So Sarah's got 3 1p coins, 9 2p coins in a purse. She randomly picks 3 coins from the purse. What is the probability she picks exactly 5p from the purse? So she's gonna pick out 3 coins. How can you? This is the first thing you should be thinking of. In what ways can we make 5p from the 1p's and the 2p's that are in there? So I've just a nice little drawing with 1 1 1, and then 1 2 3 4 5 6 7 8 9. They are all our 2p's. Now the ways in which she could get 5 pence are, well, you can't add all the 1p, that would get you 3p. So 1p, 1p, 2p, that would get you 4p. That doesn't work because there's 3 coins, so it's going to be 2p, 2p and 1p. So 2p plus a 2p plus a 1p equals a 5p. But it don't necessarily have to do it in that order. You could have done a 2p, then a 1p, then a 2p. That's going to give you 5p. Alright, so I'm just going to put all there. Or you could have done the 1p first, and then the 2p, and then the 2p, and we could have got 5p. Okay, so what's the probability that we're going to pick out a 2p first? Okay, that's the first thing that we need to think of. So there are the 12 coins, and 9 of them are 2p's. So 9 out of 12. Then we're going to multiply that by the chance of picking a 2p again. Well, that original 2p doesn't go back in, so it's conditional probability. It's 8 out of 11. And then the chance of picking a 1p, well, there's 3 of them in there, and that is going to be out of 10. Okay, now we've got the same thing here but just in a different order, so we're going to think of this being one calculation. Then we're going to add it to this calculation, which is exactly the same numbers, just in different guise basically. So we're going to get the 9 out of the 12 again, then we're going to get this time 3 out of 11, and then we're going to get the 8 out of 10. All right, so it's still going to give us the same result, it's just a slightly different way of doing it. And then, or we've got this other way of doing it as well, so we've got 3 out of 12 this time. Then we're going to multiply by something out of 11 and something out of 10. You can just pop those there because we know that's what the bottom numbers are going to be. We've got 9 of those and we've got 8 of those. Okay, so if we just type that in to our calculator, we could do it all in one go. In fact, a nice quick way, we could go 9 out of 12. Just do it, oops, better with the mouse. And multiply it by 8 out of 11, multiply that by 3 out of 10. And then close that. Now that gives us that answer, 9 out of 55. So that's what that gives us, all right? Just add it to that and add it to that. So we can add the answer, because it's going to give us the same answer, and the answer again. So answer plus the answer plus the answer. And that is going to give us 27 out of 55. Okay, so equals 27 out of 55. Simplified version of our fraction answer, or equivalent, anything that we've got. If we did it without a calculator, it's possible. But that is the chance of Sarah randomly choosing 3 coins and picking exactly 5 pence from the purse. All right, so I'm hoping that makes sense to you. Conditional probability, slightly trickier version of that question, but in essence, I think it starts off quite simple to understand. All right, probability of A multiplied by the probability of B if A in fact did happen in the first instance. All right, that's kind of how you got to think of it. All right, have a lovely day. Take care of yourselves. Bye bye.